Okay, so a quick lecture on SQS, simple queue service. So as we know, SQS is serverless. It's a managed queue that it's fully integrated with IAM for security. The beauty is that it has extreme scale for SQS. For SQS, you don't need to provision anything. The main purpose to SQS is to decouple between your services to be able to scale them independently and perform so work asynchronously. Okay, SQS does not handle big messages. The max message size is 256 kilobyte. So in case you want to send maybe around 10 MB file through SQS, you would instead upload that file into Amazon S3 and then retrieve the S3 key of your object and then send that through SQS instead. Then your consumer would retrieve the key and then retrieve the message from S3. This would work just fine. Okay, so all the messages from SQS queries can be read from EC2 instances and they can be managed by an auto scaling group, or it could be an AWS Lambda function using an event mapper. Another common architecture with SQS is to use it as a write buffer for DynamoDB. So instead of directly writing to DynamoDB and maybe getting some throttling issue, you would first write to SQS, okay, and it could scale seamlessly through your file, and then you would have an application dedicated to take these writes from SQS and write them into DynamoDB. Finally, there's a SQS FIFO, and for first in first out, FIFO first in first out means that the messages are received and read in order they were sent, and then because there is this ordering constant with FIFO, then you get 300 messages per second without batching and up to 3000 messages per second with batching. So there is this limited scale here. In terms of idempotency, because messages here can be processed twice, okay, by consumers. In case there is a failure or timeout or something like this, you need to make sure that your consumers are idempotent. And what is idempotent mean here? So that means that if you process the same message twice, if you do the same action twice, then the effect will not be duplicated. So we'll show the effect will not be duplicated. So we'll show you an example right now. So we are polling messages from SQS and we are doing long polling in order to minimize the cost and minimize latency, and our EC2 consumer is writing into DynamoDB, and after writing into DynamoDB, our EC2 consumer will delete the message from SQS that it's not processed by another, that it's not processed by another consumer. Okay, but in case something goes wrong, then your EC2 consumer will do two writes into DynamoDB because he will read the same message twice. So if you are inserting into DynamoDB a new row anytime you read from SQS, it's not idempotent, okay, because if you read twice the same message, then you will insert two rows into DynamoDB. But if you are doing an insert into DynamoDB using a primary key, for example, then in that case the message or the existing DynamoDB is just going to be overwritten or updated. Therefore this is idempotent because there will be only one row at the end in the DynamoDB, and if you write that message twice, so just remember idempotency is very important when writing an EC2 consumer or any kind of consumer on top of SQS. Okay, now let's see that Lambda can read from SQS and let's see that Lambda can read from SQS, and using an event source mapping, so the event source mapper will poll from SQS and return a batch and then invoke a Lambda function with that batch. So the way the event mapper works is that it's by default uses long polling, so it's optimized in that regards. We specify a batch size, so between 1 to 10 messages. If we do one message, then we are reading as fast as we can, okay, message by message. If we are doing 10, we are going to be more efficient, and then we have to configure it. So this is very simple. The event mapper says which SQS queue you are reading from and what is the batch size going to be. Okay, so the recommended value through that would be for the queue visibility timeout is to 6 times the timeout of your Lambda function, and that is from the recommendation, from the documentation. And the idea is that if you are reading the same message multiple times, and you want to make sure it doesn't time out in your Lambda function, okay, so to use a dead letter queue, you can set it up as at the SQS queue level, not in Lambda. Remember, you should not set the dead letter queue in the Lambda. The dead letter queue for Lambda is only when you have asynchronous invocation. So in case you want messages that you can't process, that can't be processed, to be removed from your queue, then you need to set up a dead letter queue on the SQS queue itself, not in the Lambda function. This will not work. Okay, so or we have seen there is a newer feature on Lambda called Lambda destination, in which case, like using Lambda destination, we can have Lambda function itself throw away these events that don't work for us into a destination, and the destination can be a SNS, or any an SQS queue, for example. So okay, one last solution architecture with SQS. We have our client, and he wants to do a lot of work, but we are going to decouple things. So we are going to put these things into an SQS request queue, and there's going to be a work processor reading from that queue and doing the work. When it's done, it's going to send a message to an SQS response queue, and the clients will be reading from that queue. Why would we have such architecture? Okay, first, well, we will get full decoupling, so we can scale the left hand side and the right hand side independently. There's fault tolerance, so in case something fails in our work processor, another work processor will pick it up, and then we have load balancing, so we are able to scale horizontally in the way we are handling request. And on top of this, SQS itself scales really well. So this is good, just an idea of architecture, but again, SQS is really SQS, it's really up to finding the question. But anytime you see some decoupling and making sure that work can be processed at least once, then SQS is going to be a great answer. All right, and that's it for this lecture, and I will see you in the next one.